Here's the effect that we'll be creating today. It's a Lego style fluid simulation. The video is divided into 3 sections: the fluid effect and the fluid material, the build effect, and the third section is the pile of bricks that gets smaller while the building effect happens. In this tutorial we'll be covering fluid simulations, dupliverts both for effects and optimizations, and we'll also be learning about particle systems, rigid bodies, and explode modifiers. So we're covering quite a few techniques for this effect. For those of you that know your stuff, all I'll say is that the techniques we use for the main parts of the effect are a fluid simulation, a remesh modifier, and dupliverts. So for some of you, that might be enough and you might not need the rest of the tutorial, but for those of you who thought I was speaking gibberish, well, we're going to go through it step by step. So the first thing we need to do is create our fluid simulation, and that's the system that's going to underpin this whole effect. So what I need to do is add some objects that are going to be part of my fluid simulation. So I'm going to add a cube. I'm then going to immediately duplicate it, scale it up, and change it to be wire display type. And this object that I'm scaling up is going to be the tank that is going to contain our water. And we don't want it to be too big because that will slow the simulation down. So we're only going to make it the exact size we need the simulation to be. This is going to be the fluid that is already in the tank. So I'm just scaling that up. And you can see if a menu's popping up, that's actually the pie menus that have been added to Blender, and you just hold the key down and flick left or right to select an option. So you may see that popping up several times during the tutorial. And I'm going to duplicate this one more time. And this object here is going to be the fluid that drops into the existing water. And that's how I made that wave effect. So a really important thing to do is now to select our objects and press Ctrl A and apply any rotation and scales, because that will affect some things a bit later on, and it's always good to do that anyway. So now we're going to turn this object into fluid by going over to the Physics tab, setting it to be fluid, and it's not going to be an inflow. You could do an inflow which would act a bit like a tap and would start to fill up our water tank, and there is going to be a slight note on inflow type water simulations a bit later on. They do work fine though. I'm going to just set this to be fluid, and I'm going to give it a bit of a downward force of -1.5 so it drops into the water a bit quicker. This object, that's just going to be fluid again, and it doesn't need any changes. And finally we've got our water tank, and in Blender that is called the domain. And a few things we're going to change here. We're going to set the final resolution to be 85, and in fact I'm just going to put it all up to the final because it's a pretty simple water simulation. And one other setting I'm going to change is the end time. Currently these settings are saying that it's going to simulate 4 seconds of fluid over our 10 seconds timeline. So what we'd get is very slow fluid. So what I'm going to do is just turn it up to 7, so it's still not the full 10 seconds, but it tends to give a good speed. If you want it faster or slower, just play around with these values. So now we're all set to our fluid simulation. All we need to do is press bake. And now that the fluid simulation is finished, we can see that our domain object has actually turned into the fluid. So what I want to do is go into wireframe mode and move our original objects. So I'm going to press M and then Alt 1, so they get moved to the layer below layer 1, because we don't need them anymore. And I can turn our fluid object back to solid mode. And if we just run through, we can see it plays back pretty quick, drops down, causes a wave, and then splashes about a bit. So what we're going to do now is add a modifier to our fluid. And that modifier is remesh, which is used to change the topology of a mesh. You can see it's removed a part of our fluid because we've got removed disconnected pieces on. I'm going to turn that off to bring that back. And the specific mode we need is blocks. So it doesn't look like it's done anything. I'm just going to turn this up to 6 to make it a bit higher resolution. And if we go through now, it's obviously a bit slower because it's having to do some conversion. But you can see we're starting to get a blocky effect. The only problem with this is that we can't specify which type of block the parts of our mesh get replaced with. It just replaces them with a generic block, and we need to replace them with a brick, obviously. I'm just going to quickly turn up the scale, just makes them a bit smaller, and we're going to be using something called dupliverts to replace these blocks with our specific brick. But obviously we need our brick first, so that's what we're going to do. I'm going to very quickly make a basic Lego brick. So I'm going to add a cube, scale it up because Lego bricks aren't cubes, they are more like cuboids. I'm going to go into edit mode and press Shift S, cursor selected, so it's on that top face, and I'm going to add in a circle, and I think 10 should do it for the ring, and I want to fill it with a triangle fan. Then I'm just going to extrude upwards. I'm going to select all connected vertices with L, and then scale it down a bit, and then just make sure it's intersecting the cube. I'm then going to take the base, and extrude it inwards with E, scale it down, into wireframe mode, flicking right again for those pie menus, and then just extruding up inside. So what we have is a very basic Lego brick, and obviously you should spend more time doing this. You know, you can add a subsurf, beveled edges will look very nice. One thing we are going to do is set it to be shaded smooth, so I'm just going to press space and type smooth, because we need that curve at the top to be smooth, but we don't need these edges to be smooth. And it actually looks a bit weird and adds artifacts in, because these edges have a very high angle and it's trying to smooth between them, which obviously isn't possible. So we're going to add an edge split modifier, which will split the edges depending on the angle. We want a very high angle edge to be split, and a lower angle to not be split. So if we just turn up this number a bit, we can see that it retains the smoothness on this curved part, and retains the flatness on the rest. So I'm then going to scale it down a bit, and I mentioned dupliverts before, and we can find them if we go to the Object tab, down to Duplication, and the Verts option. And these options are called Dupliframes, Dupliverts, Duplifaces, and Dupligroup. So we're going to choose Verts, and nothing happens. And I think this is a bit of an issue with the UI at the minute, that it doesn't really give a warning of why it's not working. And it's not working because it expects an object to be parented to this object. So we've got our brick object. I'm going to parent it to this one with Control P object. And you can see we've now got a big mess of cubes. So what dupliverts actually does is say replace every vertex in this mesh with another object. And the object it's using is the child object we just parented. Unfortunately, it is replacing it at the location of our brick object, and really what I want is it to be on top of our fluid object. So I'm going to press Shift S, cursor selected, select our brick, and Shift S, selection to cursor. Now, one problem we've got is that the cubes are a bit big, so I'm going to scale them down just by scaling our original brick, and as we scale them down, we just want to have a slight gap in between, so I'm going to scale them up a bit, and there we can see we've replaced every vertex in the mesh with our brick. And if we play through, you can see we're getting a pretty good Lego effect. Now one thing I want to do is explain why we're using dupliverts and not particles. If we had this and we said, right, well we could use particles to replace every vertex of the mesh, and you know there are some advantages of using particles because we could have slightly randomized rotations and things like that. The only problem with particles is that it expects to know a specific number of particles you want, but unfortunately with this fluid we simply don't know how many particles we would need, and so you could say, oh well I'll just put the particles up to a really high number, but if you did that and it needed less, you'd start to get particles overlapping again. The great advantage of dupliverts is that you don't have to specify how many duplicates you want. It will just do it automatically and adjust as our fluid gets bigger or smaller and needs more or less duplicates. There are a few issues though that we're now going to fix. I explained that our brick was more of a cuboid, and it's not actually a cube. However, the remesh, if I just turn duplication off for a minute, the remesh is turning everything into cubes. So when we turn verts on, all of our bricks are being overlapped. We can see this one is overlapping the bottom of the top brick. And one thing I just want to point out is that when we have everything selected, it's actually quite intensive to draw the outlines of all these selected objects, and you may find the viewport slowing down a bit. So if you just make sure you've got it deselected, we can navigate a lot quicker. But as I was saying, our bricks are currently overlapping. So what we're going to do is stretch our fluid simulation to be a bit taller so that our bricks are no longer overlapping. And to do that, we're going to use something called a lattice. And a lattice can be found in our main add menu, and it's a special type of object which can stretch objects which are connected to it via the lattice modifier. So I'm going to scale it up so our object is within it. I'm then going to change some of the lattice properties, and what I'm going to do is change the V, which is the vertical coordinate, to have 6 subdivisions. And this is just because when we do the stretching, if we only had 2 subdivisions like it originally had, then the stretching effect wouldn't be uniform over the whole of the object. So we've got our lattice, we're going to connect it to our fluid by adding another modifier under the remesh. The modifier is, here it is, it's lattice. And you can see everything slowing down again because I've got the fluid selected, so I'm just going to deselect it. And it's looking for an object, and a nice clever trick we can do is just to press E over the object field, and it brings up the little eyedropper, and we can pick the object that we want to use as a lattice. So now it's put that object in there, and so we can manipulate our lattice now. So if we go into edit mode, we get something that looks quite familiar. It looks like it's just a mesh with vertices, but we can do something a bit more interesting. So if I were just to move one of these vertices, we can see we're stretching and warping the mesh. So I'm going to select all of them. I'm going to zoom in close so I can see our bricks. And then I'm going to press S and then Z. So we're scaling the lattice to be taller. And you can see our bricks are starting to separate. So I'm just going to scale it so we've got a tiny gap. Our bricks are no longer overlapping. And you can see our fluid simulation is a lot taller now. So you may want to go back and think, well, actually, if it's going to be this tall later on, I'll make it a lot shallower to begin with. And so I'm just going to move our lattice to the layer below again. So I'm going to press M and then Alt-1. Because we don't need it anymore. One problem you might notice is that as I scroll through, at the bottom we're getting this slight jitter. It's moving up and down. And that's because of the way the remesh works. It basically kind of generates a grid in order to turn our object into blocks. And as the size of our object changes, the grid tries to adapt. And so that's what this movement is. It's the grid adapting to the size of the fluid. This can actually be seen more on inflow type fluid simulations, and I will show you an example of that in a minute. And so one way to fix it is to stop the remesh from adapting to this fluid mesh. And we can do that by adding in some extra geometry. So I will add a cube at the top here, and I'll scale it down. I'll go into edit mode, duplicate it along the X, and what we want to do is contain our fluid within kind of a box. And these are the corners of our box. So then I can select everything, move it on the Y-axis, so this is one side of our box, duplicate it, and this is the other side of the box. So you can see we've contained the fluid within the bounds of this object. And what I'm then going to do is add another modifier, And this time it's going to be a boolean. And I'm going to put it above our remesh. And I'm going to set it to union. And again, I'm going to press E. Select our object. And you can see it's joined these cubes into our main remesh. And if I just turn off the lattice, you can see the duplication has actually added more duplicates at these new cubes location. But if I scroll through now, it's a lot slower because it's having to do a lot more work, but we're getting no jittering effect. And that's because the remesh is now no longer looking at the bounds of the fluid, it's looking at the result of the boolean. So the bound is no longer this fluid, the boundary are the vertices of the cubes we joined in. And so those cubes are never moving, and so it will read the maximum dimensions the grid needs to be for the remesh and never change it. So if I turned that off, the grid would be adapting to the size of our fluid and jitter. If I join in more objects via a boolean, it looks at the new maximum values and doesn't have to adapt. But because the grid size has changed a bit, our bricks have also changed a bit. So all we need to do is scale up our original brick a bit more. And if we turn our lattice back on, our bricks are all at the correct size. So that's obviously, an improvement. We're not getting any jittering. The problem is, we've now got these weird sets of cubes at the corners. We obviously don't want them to render. So we will now add in a second boolean to remove them again. So I'm going to add another cube, and I will set this to be wide, just like we did with our domain. And it has to contain our fluid, but it has to miss out these blocks. So what I'm actually going to do is move these bottom blocks a bit lower. They need to be outside this new box. So if we go back to the modifiers, we're going to add a boolean. It's going to be above the lattice, so we're basically surrounding our remesh with two booleans. And again, press E, we'll sample this box, and it has now cut out those extra duplicates. And I can press Ctrl H to make sure these objects are hidden from render, and do the same for this one, Ctrl H, and then I will move them to the lower layer. So what we're left with is a stable mesh. So again, it is going to be a lot slower because we've got so many modifiers now, but we're not getting any jittering. So I'm just going to reiterate what we've done. We have added in some extra geometry, so we are creating a new boundary for the remesh to read, so it no longer has to adapt its size, and we're then removing those duplicates because obviously we don't want to see them in the render. Now, I said this was more apparent with an inflow, and I happen to have, if I just save, happen to have another scene that has an inflow setup, and I've got exactly the same setup. You can see we've got our boundary cubes, and then we've got our inner cube, and if I play through, we get, again, a stable effect, but we're using an inflow. But people who are using an inflow would also see an added problem. So I'm going to turn off the booleans, and we can see what's really happening to the remesh as it adapts. You can see at the beginning, the remesh will look at this object and say, well, it's within this small area. I will stretch our 6 subdivisioned remesh grid around the object and turn it into blocks. And so we get very small blocks. And I'll just enable another layer with a grid. And you can imagine that this grid is being overlaid over our object and doing the remesh. But as our object expands, this grid is being stretched over our object. And so it looks like that. And so obviously we're getting bigger cubes later on as the remesh adapts. So our remesh is no longer adapting at the beginning because it's reading the boundary from these cubes at the edges. So now what I'm going to move on to next is the materials for this. And the material works by calculating the height of the bricks and colouring them dependent on that height. So it's not hugely intelligent. We're not using velocity, as we can't get that data from the fluid simulation. We're purely saying that if the bricks are at a certain height, they will be a certain colour. And so now would be a good time to add a world. So I'm going to use nodes and set it to white and maybe turn it down to 0.7. So if we go into the rendered view, we can see we've got our nice bricks, and you can see they're all separate. And obviously you may want to reduce that lattice so the difference between the blocks is a bit less. It'll do for now. So how do we get those colours to vertically be mapped along the height of the object? Well, we're going to do that now. So I will split our view out. This will be our node editor. And so we'll go, we actually add the material onto the brick itself and not the fluid. That's very important because it is the brick that is kind of being rendered. So we'll do new material. I'm then going to go onto the object tab, and the first thing I'm going to do is add a texture gradient, and that's how we're going to create those different levels of colours. And because I have the Node Wrangler add-on enabled, I can just Control-Shift click on this node, and it will connect this node directly to the output. And you can see we're kind of getting a gradient on each brick. We don't really want that. We want a gradient stretched over the whole object. So I'm going to input the object info node, and for the vector of the gradient, I'm going to put the vector of the object. And so now it's looking at the location of each of these duplicated bricks and mapping the gradient depending on that. So it's kind of acting as one big object. But we do need to manipulate this gradient a bit because it's kind of facing the wrong way. So I'm going to add a vector mapping node, and what we want to do is rotate it on one of these axes. I'm not sure which one it's going to be, so it didn't seem to be that. Let's try the Y, and we can see we've now flipped our gradient to be pointing upwards. So what we need to do now is manipulate this vector a bit more. It looks like the X is now affecting the height, and what we want to do is map the black to the lowest part of the mesh that we want to be a specific colour, and we want the white to be the top, and we want it to be different levels of grey in between. Currently we've got this big section of white, so that means all this section is going to be one colour. That's fine if you want it like that, but I wanted to have different steps of colours along the top. At the minute we're only going to get a few steps of colour here. So to do that, I'm going to scale down our gradient and then move it down a bit more. And so you can see we're getting a lot more steps now. So I'm going to continue to manipulate this. And so that looks pretty good. We're getting a good gradient from top to bottom. And if at some point you change the Z location of the fluid object in 3D space, you will have to come back and alter this material again, because the Z mapping will not move with the object. So if the object moves, the material may appear higher or lower on the object. But at the minute, we're using the gradient's colour, and that's just going to be black and white. What we can actually do is map new colours. So we'll go to Converter, Colour Ramp. We'll slot that in so it's connecting to the output. We're seeing no change because this colour ramp is just using black and white. But if we start to add in a few different colours, we can start to see our effect. And so I'm going to add a series of different blues in to represent the different heights of the water. So you can see we've mapped a few colours, but for me this is changing colour a bit too much. So I'm going to change the interpolation mode of the colour ramp to be constant, and that makes it a constant colour. I'm actually going to add in a few more blues. So that should do it, and it's looking very flat because we're just viewing the colour we need to put it through a diffuse shader. So I'll plug that in. And now you can see our bricks are getting coloured. And if I just go back to the beginning, you can see we've got this wave going across. And actually, I want there to be a bit more white, and I want this to be a slightly different blue. And I want there to be a bit less of it, and we can just add more or less of the colour we want. What I also want to do is obviously not just have this as diffuse. Lego bricks are slightly glossy, so I'm going to add a shader, mix shader, and then add a shader, glossy. And I'm going to set the mix to be 0.3 and the glossy to be 0.3 and give this a white colour and mix them together. And actually I meant it to be 0.03, so they're only slightly glossy. And now's going to be a good time, because we've made it reflective, now's going to be a good time to update our world. So I'm going to add in an HDR, so texture, environment texture. I'm going to browse to an HDR, and it's a mirrorball, and I'll connect it to the colour, and then I'm going to rotate it. So I'm going to add in a input texture coordinate, and then a vector mapping node, and connect it to generated, and now I can rotate my HDR until I get something a bit more interesting. So what I can then do is, we can see that we're at 100 samples for the viewport, but we're still getting a relatively noisy result, and that's because we're using an environment texture now. And something we can do is, in the settings of the world, is enable multiple importance sampling. And that's just kind of an improved sampling. What it actually says is you should enable this sampling for non-solid colours. And an environment map is a non-solid colour. So if we enable this and then increase it to maybe something like 1024, we get a lot clearer result. But now what I want to do, I can see it a lot clearer now that the sampling's improved. It's looking quite uniform. And what I'd really like to do is add some random colour into some of these bricks, because as bricks get older, they start to discolour a bit, especially the white ones. So we're going to add in some random variation. So we go back to the Object tab. If I press Ctrl-Shift again and click each time on this node, it cycles through the outputs until we get to random. And so what I want to do is mix in this random colour on top of these blues. So to do that, I'll add a colour mix RGB, and I want to plug this random value, so if I just press Shift to create a connector point, I want this to go into the bottom here, and I can now remove this connector point with Ctrl X. If I connect up the output, it's obviously not looking quite right. I need to set this to multiply, so it only adds on the dark parts. And that's a bit too much, so maybe 0.15. And it just adds in some subtle colour variations onto our bricks. So for those that only wanted to know how to do the fluid simulation part, that's basically the end. There's no more to add to this. The next thing I'm going to cover is how to do the Lego build-up effect. So I'm going to go into solid mode, collapse this down. So to create the build-up effect, I'm actually going to use a separate mesh, but it has to be based on this fluid simulation, so that when you transition from the build-up effect into the fluid simulation, it will match perfectly. So to do that, we go back to the beginning of the fluid simulation, we take this fluid mesh and we press Shift-D to duplicate it, press Escape to cancel the move, and we press M2 to move it onto layer 2. Now we can see it doesn't have any dupliverts because it will need its own child object to get the dupliverts to work. What we're going to do first is save, then we're going to apply our fluid. So that applies the mesh in its current position, and we're then going to go through and apply some of these modifiers. So we're going to apply the boolean and the remesh and the other boolean, but we're going to leave the lattice active. So now we need to go back to let 1. I'm going to press Alt-D to create an instance of this brick, move that to layer 2, and I'm going to press Alt-P to clear the parent, and I'm going to reparent it to this duplicate object. So you can see here we've got our dupliverts again. The difference is this is a solid mesh and it hasn't got any fluid on it. This is also going to need its own material, because at the beginning I think it should be kind of solid blue. I don't want it to have the gradient effect right at the beginning, because that would kind of make it look like foam. I just want it to look like solid water until it actually begins. So you'll notice that we're using an instance of this cube, so if I update this brick, the other brick will update as well. So even though it's not showing multiple users, this material is being shared by both objects, because they both share the same data. We want to have the objects still linked, but we want to have separate materials, and we can do this by changing this drop-down box. Currently it's set to share the material if the object data is linked, but we will set it to use the material of the individual objects. So we can now bring in that material to 001. It's now showing the correct amount of users, and we can now make it a duplicate of the material by clicking that user number. We'll then have to go back to layer 1 with our original brick, and what I'm going to do is change that also to use object linking, so its material kind of disappears, and we'll just reselect it there. So this is going to use material 001. Our duplicate is going to use .004, which is a copy, and they're still sharing the same data. And I'm going to change that material, and the only thing I need to do is basically remove all colours apart from the base colour I want it to be. So I don't want it to have any white or light blue. I'm just going to keep it as this deep dark blue. Now we're actually going to use a slightly different method to what I used originally to get this effect to build up, and that's because the effect I used was actually very difficult, and it also had a lot of problems in trying to render it. So we're going to use an alternate method which works just as well, and what we're going to do is use a particle system and an explode modifier to make certain parts of the mesh appear, and that's going to create the build-up effect. So to our fluid we're going to add a particle system. The number of particles it has is going to be the number of verts the mesh has. So in edit mode I can see the number of verts is 4,746. So 4746. I want it to last the whole 250 frames, and I'll explain why in a minute. And I want them to last 250 frames. We're going to be emitting from the verts, because we want each brick to be able to appear separately, and we don't want it to be random. We also don't need any physics, because they don't actually have to move anywhere, they just have to disappear. And we're also going to turn off halo. Now halo shouldn't actually matter, it will only matter if you're using the internal renderer, but we're just going to turn it off anyway. So if I go into wireframe mode and play through, we can't actually see anything. So under display, I'm going to click point, so it's going to display points for the particles. I select it, and you can see they're playing from top to bottom basically. At this point you may have a different emission pattern. It may already be emitting from the bottom corner to the top, which is what you might want. I was actually surprised that it was already in the correct order, so for the purposes of the tutorial I changed mine just so I could show you how to fix it if it isn't already emitting in the way you would like. But what I'm aiming for is to get the particles to emit first from this corner and end in this corner, and then start emitting from this part of the mesh and then up to this part of the mesh. So it may already look perfectly fine to you, and if it's emitting in the right order, which is the order it will end up building in, you don't have to worry about the next few steps. But if yours doesn't look quite right or not quite how you want, we'll go through a few simple steps to be able to completely customize how your Lego builds. So to do that, we can sort the elements so they emit in a different order. And by elements, it means edges, faces, or vertices. And to do that, we go into edit mode, and I'm going to place the 3D cursor. And what we're going to do is sort the elements depending on how close to the 3D cursor they are. So this will be furthest away, so it will emit first, and this will be closest, so it will emit last. And we can find the sort tools by going into Mesh, Sort Elements, and we're going to sort them based on cursor distance, and we're sorting the vertices, and then I want to set it to reverse, I think. Back to beginning. And if we now play the particles, we're seeing this is the order they now play in because we've sorted our elements. Now I did say I wanted this to play a bit after, so what I can do is actually resort these elements but make sure that this part of the mesh is a bit closer. And to do that, we can go into edit mode. I'm going to select one of the faces and press L to select every connected vertex, and I'm going to do Shift S, cursor to selected. I'm going to go into object mode and add a temporary empty, and this is just to remember the position. I'm then going to reposition the cursor to roughly where we had it, and in edit mode I'm going to move this mesh to be closer. So now it's going to be closer, so when it's sorted, it should be sorted after this part. So we'll try the sorting again. We'll select everything, Mesh, Sort Elements, Cursor Distance, and then in the toolbar we need to remember we want to sort the vertices, and actually we want to move this part of the object back to where it was. So in object mode we press Shift S, cursor selected, so we've moved it to that empty. We can get rid of that empty now. We go into edit mode, L to select all of the mesh, and then we do Shift S and we do selection to cursor but with offset. So now we've moved it back to exactly where it was. If we play back, we should see that the bottom part will play, albeit very slowly, and then the top part starts to play. And that's exactly what I want. So we've got the particles emitting, but we're not actually affecting the bricks at all yet. And to do that, we have to add another modifier, and that's going to be the explode modifier. And we don't want to see the unborn particles, but we do want to see the alive particles, and they're not going to die in our timeline, but we'll just leave dead checked. And you can already see it's updated, so let's have a playthrough of that. And you can see our mesh starts to build up. So I would like to explain why we're using the whole timeline. We're using all 250 frames, and that's because, well, I can show you. If we were trying to do both the fluid simulation and the build up in the same timeline, we might use the offset feature in the fluid simulation, and we might set that to something like -50. And that would push the simulation up 50 frames, and we may then think, oh, well, we'll have the build-up effect in the first 50 frames. So if I set the particle system to emit within 50 frames, if I go from frame to frame, we get a very big jump. And that's because it's only got a certain number of frames to be able to emit all these particles. So it's having to emit a lot more per frame. So we're getting a very quick build-up. If we set this to 250, we can have a far more gradual build-up. And that's really what I wanted at the beginning. I wanted to have the very close view and build up just a few bricks at a time. And that's why we need to use the full timeline. If you used even more frames, you could have it even slower and have it, appearing very much brick by brick. Obviously that would be very long and might be a bit boring to watch. And so what I suggest doing is finding out what speed you like, maybe render out sections. If you remember in mine, I cut to different views so you weren't having to watch the whole build-up process, because obviously it'd be quite slow and boring. So you can use editing to speed up this slow process. So that's the build-up effect done. And so as long as you rendered them from the same camera angle, both the fluid and the build-up would match each other, with a bit of editing, of course, just to get them in the right order. So one of the last things I'm going to do is building up that Lego pile. If you remember, as this was building up in my original animation, I had a pile of bricks that was actually going down. And I don't actually show it too much, I only show a few shots of it. But I will just show the effect of how to do it. And it's going to be a similar effect to what we've done here, but we're going to use a few different techniques to create the pile. So I'm going to duplicate our cube again with Shift D, and I'm going to move it onto layer 3 with M and then 3. And I'm just going to clear any parenting I may have with Alt P and then clear parent. And what I'm going to do is add rigid body properties to it. As you can see, it's gone green because it's being added to a rigid body group. Instead of convex hull, I'm just going to change it to box to make it a bit quicker. You can see a box has appeared around it, and this is going to be the collision bounds. And you can see it's slightly off because the object origin is not quite centered. And one thing to note is that this time I didn't do an instanced copy, so we're only editing this copy of the brick. The other bricks will be unaffected by this. We're going to go into edit mode, select everything, and just move it down so it's within the bounds of that rigid body box. I'm then going to apply the scale of it, and then you're going to Alt duplicate these. So this time we are doing links, and I'm just going to keep on duplicating until I've got a small tower of these bricks. Now, I haven't created as many as I did in my one. This small example will work perfectly well, and you can always add more bricks to yours. And so all of these bricks have rigid body properties. I'm now going to add a plane for them to collide with. So I'm just going to scale it up, and remember to apply the scale. And I'm going to go over to physics, add rigid body, but this time it's going to be passive. And I'm just going to turn up the friction so that they stop quite quickly. I'm going to put it below all the bricks and maybe just scale it up a bit more, and again apply the scale. And I'm just going to go back to the beginning and then press Alt A to start playing this. And you can see it's very quick. So now we've got a very rough pile. What we can do is freeze them at this position, and we do that by selecting them all and then doing Control A, apply the visual transform. And that's made the default location to be this now. Instead of all lined up in a tower, they would now start in the pile position. And we can now go to the Physics tab and remove the rigid bodies. And we're going to do the same for that. And I'm going to make another duplicate with Shift D, and this is just going to be a spare we're going to keep for the moment. And remember, they're all linked. What I'm going to do is go into edit mode, and I'm going to line up my view with the object origin, this little dot here, and I'm going to do a control loop and just slide it over. I'm then going to press F to fill that loop with a face, and then press Y to separate it. And you may be wondering why I'm doing this, and that's because if you've got a huge pile of rigid bodies, and it doesn't matter so much with this small pile, but if you've got a huge amount, it's really more beneficial to use dupliverts for them. So we're going to replace all of our objects with a plane, and that's what I've done here. I've made a plane at the object origin, and then I'm going to Control I to invert the selection and delete vertices. So we're left with a plane in the exact position that our brick was. Going into object mode, it updates the rest of the objects, and we can enable double-sided just to make the shading look a bit nicer. So we've replaced all our bricks with planes, which is going to be a lot more efficient than having a huge pile of bricks. Or, you know, it could be a huge pile of bricks, that's what I had in my one. So I've selected all the objects, and I'm going to press U and make the object and the data a single object. So they're now all separate. And they need to be separate because we need to apply the rotation and scale on them. So at the minute they all have different rotations. So apply rotation and scale. And I'm then going to press Ctrl J to join them into one big object. I'm then going to take out spare brick, and this is why we had the spare. I'm going to clear the rotation with Alt R, so it's now pointing upwards, and I'm going to find the center of this mesh. We can do that with Shift S, cursor selected, so we can see the center is here. We're going to move this object to that center with Shift S, selection to cursor. We will then parent, as we did in the other instances where we used dupliverts. We're going to parent this brick to our object by shift selecting it, press Ctrl P, and do object, and then on this object we're going to enable duplicate faces. So what you can see is we've kind of restored our bricks, but this time they're duplicate faces. And that's just going to be more efficient. It's more efficient in the viewport, it's very quick, it's far quicker to have a few thousand duplicate faces than to have a few thousand objects. It's also going to make the file size a bit smaller, and it's also going to be quicker to render. It's also very helpful to be able to turn duplication off, so that if we did have a huge pile of objects, and it was obviously slowing everything down, we could just turn off duplication and everything becomes quick again. And then when we need to render, we just turn it back on. But as I said, with a small pile, it doesn't matter so much. So now that we have our small pile, we're going to do a similar technique as to what we did before. So I'm going to select our object, add a particle system, and the number of faces, because we are going to be emitting the faces this time, is 432. So I'll set the number of particles to 432, lasting for 250 frames with a lifetime of 250, emitting from faces. We're not going to use random. We don't need any physics. And I'm just going to turn off halo. And I'm going to enable point. So we've done a very similar process as to what we did before with the other build-up effect. And I will now add our explode modifier like we did last time. This time we need slightly different options. Because we're doing the reverse, in our build-up effect we had nothing and it was growing into the finished object. We're doing the reverse, we're starting with the finished object and we want to reduce it into nothing. So I don't want any alive particles or dead particles, I only want unborn. So if I go back to the beginning, we have a whole pile, and if I play through, they start to disappear. However, we want to make sure that particles at the bottom of the pile don't disappear before particles at the top. So we're going to do the same thing that we did last time and sort the elements, although this time we are going to use a different sorting. I'm going to go into top view, into edit mode, make sure everything's selected, mesh, sort elements, and we're going to do the view Z axis. So the Z axis is pointing right at us, upwards. If I open the toolbar, I want to make sure we're sorting faces, and we want to make sure it's reversed again. So if we go into object mode, and just to save it again, if we play forward, the top objects will disappear first, and that's what we can see happening. Now there is one property I forgot to change, and that's the jittering. We don't want any jittering because we want it all to be controlled by the sort order that we just made. So if I go back again, it should now be slightly better. We were getting a few that were not disappearing quite at the correct stage. So you can see the effect, our pile is disappearing. And if I enable layer 2, well, I first have to move them out of the way, so I'll move our particles, not forgetting our extra duplicate object. I don't want them to overlap. If I go back to the beginning and then play, we can see as one object starts to appear, this object starts to disappear. Now, one thing that's obviously slightly wrong is that the amount of bricks is obviously far more in this object than in this object. So ideally, to match it perfectly, you would want to have 4,746 objects in this pile. And obviously for time, that's why I only did a tenth of that, 432. And then when we get to the end, one object is fully appearing, and one object is fully disappeared. So just to recap what we've done, we have done our main effect, which was the fluid simulation. We gave it a material so that based on the height it would be coloured white, and as we got lower down it would get darker blue. That's meant to represent the foam. We then started to create our build-up effect, so we made a duplicate of our fluid, and using the sort elements tool we sorted our elements into the correct order and then emitted particles and exploded them so that they appeared at the right time. And then finally we used a rigid body pile to create our pile of bricks that we're kind of pretending is turning in to our finished object. And as I said, I've done it in 2 separate timelines, so you can't really kind of render the whole sequence and have it transition from this build up into the fluid. That's something you're going to have to do with editing. You could potentially have 2 separate scenes, so you would have these layers in one scene and the fluid simulation in another scene, and then you might be able to use the VSE in Blender and edit the 2 scenes together. However, the method I generally use is just to render out the image sequences, take them into a video editor, and edit them together. So I hope you have enjoyed the tutorial. I hope you've learned something new. I hope to see you in the next tutorial. Goodbye.